Hello everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. So, welcome to my class. So, today we are going to solve different problems on DC motors. So, in the previous classes, we have discussed about the construction. Then we have discussed the UF equation. Then we have discussed the types of DC generators and motors we have. Then we have discussed the characteristics of DC motors and generators. Then we have discussed the speed control techniques of DC motors. Then we have discussed the working principle of three-point starter. So the theory part is almost completed. So the remaining thing is that in this particular module is the DC motors. So in this DC motors we today we are going to solve different problems regarding that. Okay, so let us start today's class. Okay, so coming to the next slide, I think the screen is smaller, so make it a larger one. Yes, so that you can very. Yes, so we are starting with an um, example, that is a 220 volt DC machine has an armature resistance of 0.5 ohm. So first follow my pointer. First we are solving this example 29.1. So what is first written over here? So a 220 volt DC machine has an armature resistance of 0.5 ohm. If the full load armature current is 20 ampere, find the induced EMF when the machine acts as a generator and act as a motor. Very interesting problem. So to do any machine problem, first check which values are given. That is my actually opinion to all of the students, that whenever any problem is there, so first note it down what are the values are given and try to find out which thing we have to find out. So then check what you have to find out. Then to find out that question, what equation we know and what is the procedure we should follow. And if we know that, then any no problem is there to no problem is there to solve any harder problem or whatever is the problem you can solve. So you have to maintain some procedures of steps to how to deal with any kind of problem. So that thing is a very important thing. So in this particular problem, what we have that it is a DC machine supplied from a 220 volt DC supply, and its armature resistance is 0.5 ohm, and its full load current is 20 ampere. Okay, so its full load current is 20 ampere. So it is told that it is a 20 ampere. Find the induced EMF when the machine acts as a generator or motor. Okay, so here follow my pointer, two diagram we can see. Very interesting thing, follow my pointer. This is a generator diagram and this is a motor diagram. This is a generator, left hand side there is a generator and right hand side there is a motor. Now how we have to proceed to think, that we have to think like that way, that when we are thinking about a generator, correct? So in the generator we are giving mechanical input and we are getting electrical output, correct? Now the point is that when where we are giving the mechanical input, in case of generator, where we give the mechanical input, we give the mechanical input definitely where that part of that machine is rotating. Yes, what is the part of that machine is rotating? That part is the rotor. So we are giving rotor that input. So what is the input we are giving? As it is seen that if the full load armature current, that means armature current is told over here. So that's why it is presented over here. See, follow my pointer. Armature resistance, or also it is told in the problem, 0.5 ohm, and it is full load armature current, it is told that 20 ampere. Now the current direction actually is like this. See, it is the mechanical part of the machine, follow my pointer, it is the mechanical part of the machine, and from there some current is coming to the terminal where any electrical load can be connected as it is a generator. And in case of this is the motor. So in motor case, follow the direction. So we know that in case of motor, electrical energy is the input and mechanical energy is the output, correct? So this is the terminal, follow my pointer, this is the terminal from where we are giving the supply. This is the electrical end. And where is the mechanical output? This is the mechanical output, correct? And it is told that full load armature current also is at 20 ampere, because it is first initially it is taking as a DC machine. Okay, so now find what we have to find out. Find out the induced EMF. Yes, E we have to find out. So what is the formula? We have discussed that when act as a generator, so very carefully think that when we are thinking about this particular left hand side diagram, when we are thinking about this generator, that means where the energy will be generated, where the mechanical part, and from there it is distributed to the terminal. Okay, so in this armature section we have Eg, already we have been done in the previous class. Eg is a generated EMF. Eg is equal to what we have, whatever the drops is there in the armature and the rest amount of voltage is appearing in the terminal. So we know that, so this is the generated equation. Eg, follow my pointer, Eg is equal to V plus Ia. Where is the V? V is this one, the terminal voltage. And what is the Ia? Armature current given. What is the IRA? That is the armature resistance. It is also given. So everything is given. V is given 220, Ia is given 20, RA is 0.5. So we will get this answer. And now when we are considering this is as a motor, then why? See, when we are considering, follow my pointer, when we are considering this is a motor, the equation is become changed. Why? Because in that case we are considering when motor, so at that time it is not that in case of generator we are considering the input terminal is the armature. That's why Eg is equal to V plus IARA. But in case of motor, not Eg is the input terminal, this V, this one V is the input terminal, correct? So if this EV is the input terminal and this is the supply end, this is the supply in general of generator, this is the supply, and in this case of this motor, this is the supply. So if it is supply, so then where is, in the case of motor, what is the value of this EB, that is the back EMF, what should be the value of this back EMF? So whatever we have supplied minus the drop over here. So EB is equal to whatever we have supplied, how much we have supplied, this V, that is a 220, minus what is the drop, IA into RA. So see, 220 minus 0.5 into 20, that is the drop over here. Okay, so coming to the next problem, so it is just you have to think that which kind of energy is input and which kind of energy is output, and this you can understand very easily that this is a two-line problem, but you should have a proper concept. Without that you cannot solve any kind of problem, because it depends upon what is the concept you have. Because if you doesn't have that concept that okay, this is a generator, that means at the mechanical part there will be a input energy, and in the electrical part there will be a output energy, and in case of motor that is the vice versa case. So those things you should have concept. Okay, so yes, now we are doing this particular problem. Yes, it is told that a separately excited DC generator has armature circuit resistance of 0.1 ohm and the total brush drop is 2 volt. When running at 1000 rpm, it delivers a current of 100 ampere at 250 volt at a load of constant resistance. If the generator speed drops to 700 rpm with field current unchanged, unaltered, find the current delivered to load. That means what it is told, there is a separately excited DC generator which has some armature resistance 0.1 ohm, which has a brush drop, total brush drop is 2 volt. And when running at, and when this machine is running, then when this generator is running at 1000 rpm, it is delivering 100 ampere at 250 volt to a load up. That means there is an electrical terminal where it is giving 100 ampere, okay, and there is a terminal voltage of 250 volt. If the generator speed drops to 700 rpm, now the speed of the machine, which is running at 1000 rpm, suddenly its speed drops to 700 rpm, okay, and it is told that the field current is unchanged, okay. So find the current delivered to the load. Now when when it was running at 1000 rpm, the current is flowing 100 ampere. So now when the speed is decreased to 700 rpm, what should be the amount of power that is delivering to the load, electrical load terminal, where any electrical load can be connected, okay. So uh, first of all, see what is done, follow my pointer. So that is RL. What is RL? RL is the load resistance. So at the terminal, see in the problem, follow my point, in the problem what is given, the terminal the load voltage is given, the terminal voltage, and that at that load what is the power is coming, current is coming, that is also given. And applying the Ohm's law, what we can find out, 250 by 100, 250 by 100, that is giving us the 2.5 ohm. That means load resistance is 2.5 ohm, correct. Now as it is a generator, so previously we have done that. What is the formula for generator? Eg is equal to V plus IAR. So that formula we are using over here. Eg is the generated EMF, is equal to terminal voltage 250, in the problem it is given, plus IA is given 100 into that armature resistance is given 0.1 ohm. So that is the, and extra thing is mentioned over here, that follow my pointer, that is the brush drop, total brush drop is 2 volts. So we have to, if in the problem it is mentioned, always with the this EMF equation or voltage equation, always add this one. So this is the total EMF generated over here, okay. Now we know that from the EMF equation, that E is equal to NP5 by 60A. If the other remaining constant part are constant, then we can say that um, E1 by E2 is equal to E1 by E2 is equal to N1 by N2. That thing we can consider. So from that equation, so at 700 rpm, so that Eg2 is equal to, so Eg1 into 700 by 1000. Eg1, this 262 is the Eg1, into what is the 700, the reduced speed, and 1000 is the previous speed. So from there we can find out the, when the speed is reduced to 700, at that time what is the EMF value, that is 183.4 volt, okay. And uh, and in that case, when the terminal voltage that is generated EMF is 183.4, so at that time what should be the armature current value? So again we are going to use the equation. So what is the equation? So this is Eg2 minus 2, this 2 is for the brush voltage drop, minus Ia into Ra. Ia is not known to us, Ra is known to us, 0.1, is equal to 2.5 into Ia. So 2.5 is what? 2.5 is, that means in this separately excited case, whatever is the armature current, that is actually is the load current, correct? Okay. So that means, that's why instead of IL we can write down over here the Ia. So that's why that equation we are following over here. And if we solve that particular problem, we can find out the armature current over there. Okay. So coming to the next problem. Yes, let us check what is the problem over here. So this example 29.3. So in the problem, in the 29.3, it is told that 440 volt shunt motor has armature resistance of 0.8 ohm and field resistance of 200 ohm. Determine the back EMF when giving an output of 7.46 watt as 85% efficiency. So what are the values are given? So it is told that there is a voltage is 440 volt. It says armature RA is given, that is 0.8 ohm, and RSH, that is the field resistance, is also given 200 ohm. And it is told that in case of this motor, output energy, that is the terminal at the mechanical end, whatever energy is giving us, that is 7.46 kilowatt at 85 percent efficiency, correct? So if it is 85% efficiency, so what is the total efficiency? That is actually giving us the input power. So that input power is given by that formula. So we know that efficiency is equal to output by input. Now if we know the output and if we know the efficiency, then we can find out the input power. So input power formula is this one: output into that is converted, the 10 to the power 3 is for the, it is in the kilowatt, so we are converting from kilo to watt, by that 0.85, that is the efficiency that is given. Sorry, where we are, yes, this is the portion. So motor input current means, see, this is the power by input output power by the efficiency into 440. So that will give us the input current, yes. And this is the field current. Field, how we are finding out this field current? See, mm, when we are discussing about this one, so as you can see, this field winding is parallel to this terminal. So if this terminal is 440 volt, and if that, this is ISH into RSH, where RSH value is 200, so what is the value of ISH? That is a shunt current. ISH value is given by the terminal voltage by the resistance over here. So the 440 by 200 volt, so that will give us a 2.2 ampere. So what is the armature current? Armature current is equal to the input current minus the shunt current. So follow my point, this is the input current, this is the shunt current. If we might subtract that two, we will give the armature current. And after finding out this armature current, we can put the values in the equation. What is the equation? EB is equal to, as it is a motor, so we can write that, we have to write down EB is equal to B minus IA, where B is known 440, where IA is known 17 point, already we have calculated 17.75, and RA is known, that is 0.8. So just putting the values, we can find out the result. Okay, so coming to the next problem. Yes, this is a very interesting problem. So in this problem, what we have, so it is told that a 25 kilowatt 250 volt DC shunt generator has armature and field resistance of 0.06 ohm and 100 ohm respectively. Determine the total armature power developed when working as a generator delivering 25 kilowatt output, and as a motor working taking 25 kilowatt output. So here I think this is a diagram for this one. Yes, so this is a diagram. Okay, so it is giving 20, both has a once this DC machine is delivering 25 kilowatt, and once as a motor it is taking 25 kilowatt as input. Okay, so and it has a terminal voltage of 250 volt. So we know the P and we know the V. So from that to what we can consider, find out the I. So output current is equal to, this is the output power by, for the, as a generator, generator is giving delivering 25 kilowatt. So converting into watt, 25,000 watt by its terminal voltage 250. So follow my pointer, this is 100 ampere. So after that we can find out this ISH. What is ISH? That is the um, terminal voltage by RSH. So terminal voltage is given 250, RSH in the problem it is given that 100 ohm. This one, this follow my pointer. So 2.5 ampere. So what is the armature current? So what is the armature current? Armature is the summation of this load current or the line current into plus the field current. So if we add this to 100 plus 2.5, that will give us 102.5 ampere. So what is the generated EMF? In case of generator, E is equal to V plus IARA. So generated EMF V plus IARA. So that values are given. I have just plotted over here, and we can find out the result. So what is the power developed? V into I. What is the V? V means E here. So this generated EMF is 256.15. So 256 into 15 into what is the IA? 102.5. Correct? Divided, it is dividing by 1000. Why we are dividing it in kilo? We are convert into kilo. So power developed in the armature is 26.25. So that means in case of generator, when it is acting as a generator, at that time it is generating 26.25 kilowatt, right? And 1.25 is the system loss, and the rest amount of, that is 25 kilowatt, is coming to the output terminal. Okay, so now the same thing we have to do for the case of motor. So in the motor we are thinking that this 25 kilowatt is the input energy. Okay, so here the input current, what is the input current? So from there the same thing, it is 25. So coming to here at the 100 ohm, and what is a shunt is 2.5. So now what is the armature current? Armature current is the in case of generator, armature current is the summation of uh, line current and the shunt current. Here it is the difference between the load current or line current minus the shunt current. So that's 100 minus 2.5, it is giving us the 97.5. Correct? So now we know the armature current, and now the procedure same as we have done in the generator. That same thing we are mentioning over here. So IB is equal to 250 minus that 97.5, that is the armature current, and here is that armature resistance is just 0.06. So put that value, we can find out EB is 244.15. So if we know the EB, then we can find out the power developed in the armature, that is the EB into IB. Okay, sorry, EB into IA. So EB is 24.15, and IB IA is 97.5. So what is the total energy generated? That is the 13.8 kilowatt is the power total generated inside the what I can say inside the armature of the DC motor. Okay, so this is very simple problem. I'm not going to for the details. Okay, yes, torque related problem, one problem we should solve. uh, no, not this one, we should not go for this one. Yes, yes, let us do this one. Example 29.7. So in the 29.7, what we have, so it is told that a 250 volt 4 pole wave connected DC series motor has 782 armature conductors on its armature. It has armature and series field resistance of 0.75 ohm. For the motor takes a current of 40 ampere. Estimate its speed and gross torque developed if it has a flux per pole of 20 milliweber. So as I already told you that whenever there is a problem, so just note it down which values are given, and then just check how what you have to find out. So many things are given over here. The voltage is given, that is 250 is given, terminal voltage, and terminal input voltage, terminal P number of poles is given, Z, that is a 782, the number of conductors. So actually here we have to use the that EMF equation, Eg is equal to Np phi Z by 60A. But as it is a motor, so we cannot say it is a generated EMF. It is a, we have to say that it is a back EMF equation. Eb is equal to Np phi Z by 60A, and it has a armature and series field resistance of 0.75 ohm. Okay, so as it is a series motor, so total resistance is given 0.75 ohm. And the motor takes a current of 40 ampere, and in this particular series, as it is a series motor, so you can say that line current IL is equal to shunt current ISH is equal to armature current IA. All are same because it is a simple series loop, so 40 ampere current is there. Now what we have to estimate, we have to estimate its speed. Okay, so solution, come to the solution. See, here is the EMF back EMF equation. Eb is equal to Np phi Z by 60A. Okay, at the same time, Eb equation again can be given by V minus IAR. Previous problems, in the previous problem we have seen that equation. So this is sorry, this is V should not, oh there is a mistake, that should not be 50, it is 250, minus there is the armature current is told that 40 and armature resistance is told that 0.75. So put that value, we will get 220 volt. Okay, so that means there is a type printing mistake, that V should not be only 50, it should be 250. Okay, so from there we can find out EB. Now after finding EB, that value is put plotted over here, and now in the problem phi is given, Z is given, N is not given, P is given, and A is given. Where is the A is given? It is told that it is a wave connected, correct? And wave connected means A is equal to 2. So that value we will put, and after putting that we can find out that N is equal to this. So from that value we can find out the from from this particular equation we can find out the N, and after find out the N we have to find out the torque. Okay, so torque value is given by E is equal to 1.1595 Z into IA by I by P. So from there we can torque is equal to this. If we plot the put the values over there, we can find out the torque equation, that is actually coming just here in this particular problem we have to put the values only. So that is 249 Newton meter. So different types of problem we have solved today. So in this particular presentation, I have solved different DC generator problem, DC motor problem, and such problem where we have to act a DC machine as a generator once and as a motor once. So in this particular presentation, lots of more problems are there. So with I will share with you this particular presentation, so that whatever rest amount of problem that I have not discussed over here, that will be your assignment, you have to solve, and if there is any problem you can contact with me. Okay, thank you. That is all for today.